Hello and welcome to this Engerati Energy Talk where we are talking about nice grid. I still can't get over the fact that you guys call it nice grid and not nice grid, but anyway, nice grid it is. Welcome gentlemen to the studio today, and the way we're going to do this, we're going to go through each of our members of the panel. Actually, it's probably less of a panel, more of a discussion and a sharing exercise, and they'll explain about the different elements of the project and how it happened and what some of the learnings were. So just to kick us off, Thomas, can you just give us an overview of what you've done, where you are, and just to summarize and contextualize for people watching what we're talking about?
So, the Nice Grid project is one of the major smart grid projects in France related to solar PV integration. And this project has been started in 2011, involving 10 partners. So ERDF as a French DSO is coordinating the project. And we have been proceeding our different use cases, PV integration, peak demand reduction, islanding, customer engagement. So up to now, all the material has been installed on site. Everything was proven and is working on site. We have been extending the project for 1 year, for the year 2016, in order to consolidate our results.
Okay, and your role in the project, Thomas, if I may, just so that people can contextualize where you're coming from when we are talking.
So my role within ERDF within this project, this role is to implement the solution on our network. So the solution from ALSTOM, from Socomec, and from the other partners involved in the consortium. So to install and to operate everything in our grid was the main role, and also to coordinate the work between the different partners in order to reach our targets in the project.
Okay. Brilliant, thank you. And Giovanny, I will bring you into the conversation. Can you talk to, we were talking off air a little bit, and can you talk to us a little bit about, some of the storage elements that were put into Nice Grid, and contextualize your view of that side of things?
Okay. Socomec was involved inside the Nice Grid project in order to design, manufacture and validate storage solution for two types of use case inside the Nice Grid project. The first one was for the massive integration of PV production, and to try to bring some solution in order to solve the constraints bring by these kinds of renewable energy, like voltage deviation, response and demand balance. And the second use case, we were focused on an innovative solution which could be largely applied on isolated microgrid. It's the islanding functionalities.
So this storage, is it like grid scale storage? What sort of scale are we talking about?
I would say that we have integrated two types of system. Concerning the massive PV integration use case, it was, I would say, small storage system, because we are talking about 33 kilowatts and 160 kilowatt hours, located mainly at the end, at the extremity of the grid. For the second one, concerning the islanding storage system, this element was composed of 250 kilowatt of conversion, by putting in parallel several converters in order also to validate decentralized architecture, plus with the association of a SAFT battery about energy capacity around 600 kilowatt hours. So with two really targets, I would say that for the smallest one, we are mostly focused on power application in comparison with the islanding one, where we are more focused on energy application.
Okay, and Thomas, Laurent, can I bring you in, and if you can tell us sort of your role in the whole project, and also talk about a little bit about the sort of distribution management side of things a little bit as well, and then we'll go around and mix it up a little bit.
Okay, so ALSTOM Grid was now transitioned into GE Grid Solutions, has been the partner supplying, together with the ERDF, the software layer, which allows to coordinate distributed energy resources, whether flexible demand, various pieces of storage, grids, community or residential, and PV, and to make all that coordination together in the context, trying to resolve congestion at the distribution grid node level within the ERDF system. So that's one of the main elements. The second element which we supply is in the converter technology for the 1 megawatt scale battery, which has been connected into the system for being able to supply services both to the DSO ERDF grid operator, which is now fully tested, but very soon also to the TSO RTE, who is potentially going to use that grid storage for reserve ancillary services market interactions.
Is it sort of demand response type?
It's really stability,
right.
Stability reserve back into the TSO. So the software piece has particularly been innovative into that, because I think the challenge has been to coordinate devices at all layers from grid edge to medium voltage up to transmission together, bolting this on the top of a SCADA existing infrastructure. And really what is important is we demonstrated that it does work end-to-end from devices through aggregator into the distribution grid operations, and it's ready to be rolled out, basically.
And from your experience, what's it been like running a system like this? You know, how different is it from the way things used to be done? You know?
So it was also one of the challenge, and maybe one of the most interesting part in the project, because we have been involving the whole companies, technicians, our technical departments, to the new technology. When comes to storage, we had to understand the new way to the new systems, and also had to train our technicians to be able to operate the systems. At the end of the day, we had no reluctancy from our technicians, for example, but a great enthusiasm to take part into this project. So it makes the thing a little bit easier to implement the different systems that we have, for example, on our regional control center, at our operational basis. So we had a great enthusiasm and also a good understanding from our side of the new technologies.
And when you go into this new world, I mean, are there any significant differences, or are you now, having experienced this, having a sort of mindset, well, why haven't we done this before? Does it feel very natural now?
To use of these new technologies, we have actually we have been this project is kind of a little bit getting forward to the future. What photovoltaic will look like in the future. We selected a very specific district and city where we already have some grid constraints. So we have been developing the technologies, and at the moment, for example, we look at at other primary substations where we could replicate the system, but the solutions involved in this project are more at the moment, because we have the photovoltaic is getting stronger in France, but it's still we are still in a path of progression. And so the solution that we developed, we implemented in Carros, we are looking at the moment where we can maybe implement this other solution, but it's still for us regarding the photovoltaic development, such an early stage. What we got, for example, storage, but for other solutions, we have been also installing, looking for installation. We installed some materials in other primary substations as well. And
just on that storage side of things, I mean, what were some of the challenges you guys had to overcome with it? Or, I mean, and feel free to turn around and say there wasn't a challenge, we're just put some batteries there and it worked. Yeah.
I would say
sometimes things can be easy, right?
I would say that for the first part of our project, it was, I would say, quite easy for Socomec. Socomec has a very long experience in the power converter for solar application, UPS application. So concerning the massive integration of the PV inverter use case, there is no real challenge, I would say, except the fact that we should integrate new technology of battery from SAF, lithium-ion. So the challenge was more, I would say, for the DSO, for ERDF in terms of installation. In terms of control of the system, it shows that right now, according to the original specification, we focus on voltage regulation and global voltage regulation. Now we understand, thanks to this project, that we could probably optimize our technology, our solution, by looking for some solution able to manage phase per phase voltage, the voltage phase per phase, and also probably to have a more real-time reaction, driving by a global strategy, but able to manage locally this kind of solution. The real challenge for Socomec was clearly the islanding. The islanding was a real innovation solution, especially implemented on a French grid, microgrid. And the main innovation is the fact that now we are make the demonstration that we are able to provide suitable equipment in order to provide the power supply of a microgrid during a long term, about 9 hours, without any rotary machine. And the global integration of this system, the global design of this system, implemented some very innovative solution like the islanding controller, a new technology of power converter working like a voltage generator. For us, it was a real challenge, technical challenge for the tools last year.
So basically you're saying that this microgrid can exist on its own. You can switch off the switch from the rest of the distribution or transmission network, and it can live like that for 9 hours.
Yes.
And then come back on in an easy way, because there's all sorts of frequency regulation before you come back onto the grid and so. So I suppose turning the switch off is the easy part. Getting it back.
Yes,
that's hard, right?
If you try to explain roughly the functioning sequence of this system, we have two types of islanding mode. The first one is the scheduling islanding. In this case, according to the flexibility requested by the software coming from ALSTOM, we receive an order 1 day before the islanding in order to prepare globally the system, and mainly the state of charge of the battery. When we receive the order in real time, then the system tries to transfer the power from the grid to the storage system, and then ensure the disconnection between the medium voltage part and the low voltage part, without any perturbation for the customer, the end user. Then, after a certain period, which is also suitable by the firmware of ALSTOM, we can recover a normal situation. It means that the microgrid, thanks to the storage system, will ensure the synchronization, voltage, frequency with the grid, then ensure the transparent reconnection from the microgrid to the main grid. And during all this period of 5-9 hours, the storage system is focused on the management of the voltage and the frequency to keep these two values, main value, inside the standard range defined by the standard. And the second topic is also to manage the load, the balance between response and demand for the local microgrid.
And just to bring you in, Laurent, here, you don't try islanding something for the fun of it. There's a reason behind it, and what are some of the use cases? I mean, I can think of some as well, but I don't want to put words in your mouth. But why are we testing this, and what benefit can it have for the bigger network as well?
So there were already different use cases which we looked through. What we realize is when we island, for instance, we need to prepare the island, in the sense calculate the state of charge, anticipate. and some use cases were scheduled use cases the day before, anticipation of risks of congestion or scenario like that. Some other use cases were simply detection of failures and trying to go against an incident into the network and fail safe, improve the resiliency against this incident. And while these cases are, I think, maybe of less interest into a European network, these prove to be extremely valuable for fast-growing economies like Africa, India, where we see actually network failures on a quite regular basis. So this is showing how a distribution grid operator will improve his role of doing better resiliency in the future. It shows that it does work. The challenge which we actually had on our side was threefold. The first one was to anticipate roles of these various aggregator, grid operator, transmission, distribution, and so on. And we had to work in the same time with the context of the project and what happens at the European level through the discussion of TSOs, DSOs. And the second one was, and we did not anticipate that one, was what real-time communication is required between the various devices from grid edge down to the primary substation. And luckily we did the very wise choice with the support of ERDF to build 5 megabit per second network across the power line from primary substation down to the medium low voltage, which gives real control, fast control on the entire pocket of that microgrid.
Is that a fiber connection?
No, that's over power line carrier.
PLC,
so that was
right?
actually, and I think that proved to be a very successful part of the project. The last one, which is also important, is all that project has been made through a process where standardization has happened. New smart grid standards, communication standards have been moved to, so we also had to anticipate creation of new standards into that project and start working what's going to be the interaction of batteries together, use of new standard like IC 61850, SIM into doing, for instance, distribution marketplace integration back with the SCADA and DMS. So that has been really a challenge for doing that integration, but again, that does work in a real IT/OT environment of ERDF, and this is ready for rolling out at a larger scale in Europe and outside Europe.
When you say at a larger scale,
yeah.
I mean, paint a picture of how large this could be. Is what you've proven here going to be the default architecture for distribution networks as we see them?
So from a technological sense, we did build our platform out of industrialized solutions. So if tomorrow morning a DSO needs that for the management of its large-scale, several million of consumers, we are ready to deliver it. That's not the issue. Technology is not the roadblock here. Then comes the regulatory discussion and what the regulator is going to allow in the next few months. How is the grid will progressively embed modernization, and here there is a speed on letting the regulator change the regulation, evolve, let the DSO play a new role, and I think that's going to be more the challenge going through the next grid modernization steps.
Okay. Well, we'll let the regulators catch up. Let's go back to what happened within the project. The other piece of it is the customer engagement piece. We touched on it when we put it. And Thomas, can you just bring that to life for us a little bit? Because everybody, we've had panels. Everybody talks about, we need to engage the customer and so on, and it seems to me sometimes to be an over-convoluted issue. Maybe you should just go and talk to them and see what happens. But what did engagement look like for you guys?
So we have, in the Nice Grid project, we have residential customer and commercial customer. So these two types of customer were recruited within the project. If we look at residential customers, we reach a number of 300 participating customers. Customers can participate in several ways. They can participate according to their equipment. They can participate, for example, with tariff signals. We can offer them, for example, off-peak tariff between 12 a.m. and 4 p.m. in order for them to increase their consumption during times of high PV generation. We have also some customers equipped with residential batteries. Some customers we can remote control electrical heating. That's for residential customers, and for commercial customers we have 11 commercial customers involved, and which for them HVAC cooling group can be controlled. So the motivation for these two types of customer are quite different. What we felt, of course, these residential customers were recruited by EDF, so the retail branch from EDF, and we see diverse motivations for being recruited and participating in customer. Of course, we see the will to be part of a collective effort to support the grid comes back from the analysis from EDF. Also, of course, the consortium for environment and citizenship, and of course also the financial reward. Again, for example, when I was speaking about this off-peak tariffs, and we can offer to relieve the grid, the solution which already exists, and I was quite familiar to the residential customer. If we look at the commercial customers, it was quite interesting. We play also with communication. I mean, they created, for example, a specific logo, Engage, in Ice Grid that the companies can communicate. So we see also diverse motivation for the engaged customer, residential or commercial example.
And just taking that forward a little bit. I mean, you said there was incentives, but again, you know, one of the things that you also want to do is necessarily when you want to have a customer engage, you want to have them engaged not because you're paying them to engage with you, but they're engaged with you. You know, so where do you see that journey? I mean, you know, have you guys been able to do enough? Not you personally, but you know, the people whose job it is, to sort of get to models where we aren't paying, or they're actually participating and not. I'm not articulating my question properly. Maybe I should just say it. You know, it's that old thing about people participate because they've got feed-in tariffs, not because they want to, and the market has been designed in the right way to do that. I don't know who wants to take that. Laurent, do you have a view?
So first of all, I would not like to take the credit of all that community aspect which was created by EDF Retail, which was really a great work into trying to do some sociology around the type of consumers. Actually, 300 residential consumers starts to be a decent community, if I may say. And what we realized, taking it from this feedback, was that there is a community aspect into that project. Consumers were first intrigued. Why would the grid create a new model of pricing of energy and so on? And once the communication was well articulated by EDF, actually they realized they enjoyed it. They realized that they don't do it, in my opinion, in a lot of cases, for the sake of the voucher. And I remember having heard some interview done by EDF where the consumer was simply saying, I'm doing it for the sake of my kids learning about the interest of doing it for a broader reason. So I think we start touching the surface of having community of people trying to do their effort. And here I would like to highlight that we are in the scenario of Nice, which is in a context where consumers are used to be behind a line which is congested and so on, and who are aware of the issue of scarcity of energy in some specific grid conditions. So that's, but again, the credit should be to EDF Retail here from that point of view.
We give them due credit, and it does sound like they did an amazing job. One of the other things that I remember when we did a webinar about this on the different side of things, and we were talking about storage, a tweet came in from one of the community members, which kind of shows how engaged they are. But they also said, look, some of us have got storage in our garden as well. You know, so how did that work? You know, was that something that a use case you were trying to test and say, okay, let's put some storage, you know, behind the meter at residential level? I mean, I don't know whether Giovanni, you can sort of come in on that.
For me, it will be a little bit difficult to answer to this question because we were not involved inside the storage solution behind the meter. We are mostly on the secondary substation. Probably you have more feedback than me, Thomas, on this part.
From the residential batteries, it's really early to have some feedback because they have already been commissioned. In the last months, we have been commissioning 20 residential batteries together with ERDF and SAFT, another partner. So I think it's too early to have the feedback of the operation, which is important to notice about the residential batteries and some of other flexibilities, that everything is controlled automatically. For example, the battery is controlled automatically through the aggregators, through the network connection.
So this residential battery is still controlled by the grid, even
exactly.
though it's
exactly.
Is it behind the meter? It's behind the meter.
It's
right?
behind the meter as an appliance, so it's installed at the customer on the meter, but it's remotely controlled. So in the interest of the good point of having a residential battery, because the residential batteries are given for the duration of the project to a customer which already wants to install photovoltaic. So the good thing is to be able to solve the constraint. With the battery you can efficiently solve the constraint very close to the cause of the constraint, to the photovoltaic generators. So that's the idea of dispersed flexibilities, and with the residential batteries we can really locate the flexibility close to the PV generation.
Okay, and you know, we had another panel here where we were discussing distributed generation, and this has been like a use case of it, and a lot of sort of people on that panel were worried about when you go into this distributed world about the resiliency of the network. I'm not going to use the word grid because that's actually the wrong word. The resiliency of the network and so on. What's been your experience on that side of things? Because when you started this project, that must have been a concern, you know. And what's been your experience in it? I mean, you feel free to turn around and say, look, it's all been fine. It hasn't gone down until we told it to go down because we were testing the islanding thing. You know, can you just tell us a little bit about that side?
Actually, we have the distributed generation at the moment. So we at ERDF, so with the level of photovoltaic generation installed, we didn't reach critical level at the moment. We investigate. This is a nice good project. Different solution. We test energy storage. We test this residential flexibilities. We test also a no-load tap changer. A no-load tap changer at secondary substation with quite different type of solution. But there is of course some primary substation close to the constraint. We do a lot of prospective identifying and trying to model where photovoltaic is likely to be installed. So we have been with our technical department investigating this question. So it's not critical at the moment. The solution investigated with the nice good projects are promising. We are at the moment, so we'll look at the future when we can with the feedback. So we are studying also the whole feedback of the projects, all solution by solution, the good point, and also the thing we can also improve also together with our partners. Also a good occasion for our partners involved, in industrial partners, to improve and to tune their solution according to the feedback from the field. So we are now in the process of doing the feedback from the field, and we'll have in the future also the feedback solution by solution, and also at the same time the ERDF at the national level, because we have the Nice Good project, but also quite a wide range of different projects investigating different issues of the grid of the future, electrical vehicle, wind energy, solar energy in our case, and is scanning also all the projects which are giving at the moment their first results. We are consolidating the results to analyze which type of technologies can be industrialized and installed on a wider scale. So it's working also parallelly as the first result that we have.
Well, and the very fact that you guys are so keen to roll this out everywhere else means that the job must have been done and it works. I wonder if I could bring you in on the battery side of things as well. How important is the integration of battery technology within networks like this? Because there are people who are saying that actually we could maybe do this if we had a big scale without batteries, and so how important do you see that element of it, or do you think that we always have to have batteries and batteries need to be a part of the network now?
On my side, I think that it's very, very important to think about the distribution of the different solutions, like could explain Thomas. I think that there is no perfect solution to bring an answer to all the constraints that we are facing on the grid. For sure that if we take in consideration the first feedback coming from a nice grid, we have also to consider the concentration of the PV production, for example. We are roughly around 10%, but what will be the future of this kind of PV integration? Do we reach in the next 10 years 30%, 50%? And what will be the right solution and the right way to manage this massive concentration of PV installation? So I think that roughly it's more a work in order to simulate what will be tomorrow the grid, how our different job, métiers, tools could bring an answer for this different case. We show that for us right now it's quite difficult to give a clear, accurate answer on this topic. For sure, for Socomec, one potential opportunity tomorrow will be the isolated microgrid, thanks to the unforeseen islanding, which allow to provide power supply to each village, isolated village everywhere. But considering the situation of strong grid like we have currently in France, I think that it will be only the projection that we could be concerning the integration of massive PV production and how to integrate this production, renewable, I would say renewable production in the future.
And
so maybe if I may,
I was just going to bring you in on that
a bit here. I think what is the conclusion is clearly storage is a very high flexibility, high resiliency resource, but also high cost resource, especially when it competes to demand response or short renewable curtailment into the merit order of managing flexibility. So I think what is absolutely clear is when you decide to do that investment on the battery, you do need to integrate it into the market operation, because putting a battery, which is a device, lithium ion, again, which has a certain cost, you need to maximize that revenue out of various types. You can't just
use it twice a year.
You cannot use it twice a year. You need to optimize this across a wide range of services, especially the grid services. And so what we show here is this need of doing multi-integration, which in that case, you find business case, especially around grid congested areas.
And that's where where that sort of flexibility can actually scale up and work everywhere. So I've been signaled that we're coming to the end of our time here. So as we go, if I could ask the three of you gentlemen, please, if there is one lesson that you learned which was perhaps not expected, or that you would definitely share with someone else who's wanting to do something like this, you go, look, you have to do X, what does X look like for each of you? And Thomas, can you kick us off?
to reflect.
We give you a bit of time, Laurent. Is that
so? It does work and it does scale.
Yeah.
Okay, that's really the important part. The economics is right now being worked through, and that's the business model is not easy to calculate. That's obvious. What we also see clearly is that we need a bit more return on experience with data, and what Thomas said, we are going to continue for 1 year. By the way, watch out our Nice Grid Twitter account, because we are going to let our community know how the performance is on the system in the next few months and so on. And I'm pretty sure after next year results, we'll find the sweet spots for business case and then technology with scale.
Excellent. And yours?
For Socomec point of view, I think that it's sure the islanding. We made a new step through the smart grid, the future smart grid, and this capacity tomorrow to give some autonomy in different parts of the grid, always managed for sure by a central strategy, is clearly the best benefit that we have found inside this project. But it's clear that, like Laurent said, we need to find more services in order to optimize the return on investment of this kind of solution. It's clear.
Okay, so there are more services needed. Thomas?
On my side, what I would recommend to someone who wants an entity, a distributor or project developer who wants to do something comparable, maybe also to, not to forget the communication side, on two levels that I can give an example. I already spoke about consumer engagement, the idea to be recruiting residential customers. When you come to a commercial customer to explain the thing about energy, it's sometimes easier, but for residential customers you have to find the good words to explain them in order to engage them. And it was a great piece of work that we had to accomplish, thanks again to ERDF Retail. And also we had, for example, we set up a showroom within the city of Carros, and we did public meetings with the community in order to create this community and to inform this community to be able to engage in the project. Also on my side, on the side of the distribution company, we have quite a lot of technicians, engineers working that we have to engage in the project from the beginning in order for them to understand, to master these new technologies, and for the project to succeed. It was also a great, a very interesting challenge for us on the community side and also within a company, because it's new technology. You have to accompany this change in order for the project to succeed.
Well, that's a great place to leave it on. So despite us talking about all this technology and digitization, it comes down to people at the end of the day, all the way around. So thank you very much for watching this panel on the Nice Grid. And there are many more on the Engerati website. We very much enjoyed the conversation today. When you're watching this on engerati.com, if we've done our job correctly, below this there will be lots of links to various different places, and you can read a lot more about what these three gentlemen have done and all the different use cases as well. So thank you for watching.